Hello, everyone. Hope everyone's doing well as we have a new video where we're going to talk about arc length and the area of a sector. Um, and we're going to use our couple new formulas here to find this. So we have a baseball field here. Uh, from the distance from home plate to the outfield is 200 feet in both directions. And we're going to find how long the outfield fence is, as well as what is the area of the entire baseball field. So to start, we need to know what the formula for the area, for the arc length is. So the arc length formula is S equals R times theta. Now, R, of course, is your radius, and theta is your central angle. Now, you can't see the circle here, but if we kept this going all the way around, you would see that it's making a circle. Okay? And so home plate would be the center of this circle, and so its radius is 200 feet. So we're just going to plug in 200. And understand what we're finding here. We're finding the distance of this fence right here. This is called the arc. And we're finding the length of this arc right here. Okay? So, we plug in 200 feet times theta. Now, theta is my angle. That's the center. Okay? The central angle. So, my angle right here is 90 degrees. Okay? But the trick to using this formula is your angle has to be in radians. So we have to change that 90 degrees. We're going to plug it in. We have to change that to radians. And we do that by plugging it in with pi divided by 180. And that will automatically change the degrees to radians. And so basically, you just put this in your calculator from here. 200 times 90 pi over 180. And you will see that will round to about 314 feet. So the distance from foul pole to foul pole is 315 feet. 314 feet. And understand that is rounded. So it's not exact. It's, we did round. As far as the area goes, the area formula for a sector. Now, understand what we're finding the area of the entire baseball field here. So it's 1/2 times r squared times theta. And the same rules apply. Your theta has to be in radians to use this formula. You've been using both of these formulas for a long time. You just didn't know that, and I'll explain that to you in just a little bit. But let's finish our problem here. So we're going to say 1/2 times r, again, 200 feet. This time it's squared, times our theta, which again will be 90 degrees, but we're going to change it to radians by saying pi over 180 with it. Okay? And from there, you just put that in your calculator, and you should get 31,416. And since this is area, it is in square feet. Okay? 31,416 square feet. And again, that's also rounded. So our arc length is 314 feet rounded. Our area is about 31,416 square feet. Now, I mentioned earlier that you have been using these before. These are basically just finding parts of the circle. So the arc length of an entire circle would be the circumference. Now, you know the circumference. You know the formula for circumference. C equals 2 pi times the radius. Okay? You know the formula for the area of a circle. The area of a circle is pi r squared. You've been using these formulas for I don't know how long, but if you're talking about arc length and area of a sector, these formulas come from the arc length and area of a sector formula. And let me show you how. If I'm finding the circumference, that's basically the entire arc length of the entire circle. So that would be, remember my arc length, excuse me, I put C. My arc length is R times theta. Well, if you're finding the entire circle, your theta is 2 pi. 2 pi is 360 degrees. So therefore, that's where you get your 2 pi times r for your circumference formula. For area, it's 1/2 r squared times theta. Well, again, theta for this problem, if you want to find the entire area, would be 1/2 r squared times 2 theta, if you're talking about an entire circle. And this 1/2 and this 2 cancel. And you're left with area equals pi times radius squared, which is the same formula you've been using forever. Okay, so hope this little video helps. Y'all have a great day, and as always, stay above the line.